The enthalpy of atomization of CH4 and C2H6 are respectively 360 and 620 kilocalories per mole. Bond enthalpy of C bond is in kilocalories. CH4 contains 4 CH bonds and the total enthalpy is 360 kilocalories. So, one CH bond will have an enthalpy of 90 kilocalories. Then, the second compound is this compound. It contains 6 CH bonds and 1 CC bond, and total enthalpy is 620 kilocalories. 6 CH bonds will have 6 into 90, that is equal to 540 plus the bond enthalpy of CC bond. This is equal to 620. So CC bond will have an enthalpy of 620 minus 540, that is equal to 80 kilocalories. That is, answer is choice D. For the reaction, 2C6H6 plus 15O2 gives 12CO2 plus 6H2O. The difference in kilojoules between heat of reaction at constant pressure and volume at 25 degrees Celsius is. Heat of reaction at constant pressure is known as delta H, and heat of reaction at constant volume is delta U, and the two are related by the expression delta H is equal to delta U plus RT delta N. Delta N is the number of gaseous product minus number of gaseous reactant. Here gaseous product is 12, gaseous reactant is 15, so delta N is equal to minus 3. And you are asked to find out the difference between delta H and delta U. So the difference delta H minus delta U, this will be equal to RT into delta N. So this will be equal to R is 8.314 joules into temperature is given as 25 degrees Celsius, that is 298 into minus 3. Here the answer is in joules, but you are asked to find the answer in kilojoules. So this you are dividing by 1000. We will get the answer A, minus 7.43 kilojoules. For simplification, you take this value as 300. 298 you can take it as 300. 300 into minus 3 is minus 900. Minus 900 by 1000 into 8.314. The answer will be definitely less than 8.314. So accordingly you can choose the first answer. No need for complete multiplication and division. This point you have to remember. In most of the problems you have to do the things like bond enthalpy of NH, HH, N triple bond N are X, Y and Z respectively. Then delta H for the reaction 2NH3 gives N2 plus 3H2 is. Now using bond enthalpy you can calculate the enthalpy of reaction using the equation. Delta H will be total enthalpy of the reactants minus total enthalpy of the product. Now remember, it is only in the calculation using bond enthalpy, it is reactant minus product. For all other things, it is product minus reactant. Now this will be equal to reactant. So reactant you have NH bond. In ammonia there are 3 NH bonds and totally 6 NH bonds will be there because there are 2 molecules of ammonia. One ammonia is NH3 contains 3 NH3 bonds, 3 NH bonds, and 2 ammonia will be containing 6 NH bonds. So totally it will be 6X plus. So only this is the total enthalpy of the reactants minus then product. Product you have N2. N2 is having the bond enthalpy Z plus H2. H2 is having 1 HH bond, 3 molecules. So this will be 3Y. So this will be the bond enthalpy. So if you remove the bracket, this will be 6X minus Z minus 3Y. 6X minus Z minus 3Y. That is choice A is the correct answer. For which of the following changes delta H is not equal to delta U? The relation between the two is delta H is equal to delta U plus RT delta N. When delta N is 0, delta H will be equal to delta U. So in this question, we have to count the number of gaseous reactant and a gaseous product. If they are equal, delta H will be equal to delta U. We are asked to calculate, asked to find out the equation where delta H is not equal. So number of gaseous reactant should be different from number of gaseous product. Then only delta H will not be equal to delta U. In the first case, there are 2 gases reactant, 2 gaseous product. So equal. Second case, there are 2 gaseous reactant, 2 gaseous product. So for that also delta H will be equal to delta U. Third case, 1 gaseous reactant, 1 gaseous product. For that also delta H will be equal to delta U. For last one, you have 1 gaseous reactant but 2 gaseous product. So here delta H will not be equal to delta U. So D is the correct answer. Which of the following defines enthalpy of formation of the product? Enthalpy of formation is the enthalpy change accompanying the formation of 1 mole of a compound from its elements. So to verify whether the given equation represents enthalpy of formation or not, we have to verify only 1 molecule of product should be there and the reactants should be elements. In choice 2, C, there are 2 molecules. So this is ruled out. This is also ruled out. Here it is not an element, it is a compound. So this also is not enthalpy of formation. In the first one, carbon diamond is coming. Diamond is not the standard state of carbon. Graphite is the standard state. So this also is not the enthalpy of formation. So this represents the enthalpy of formation. Hydrogen fluoride, 1 molecule only. Hydrogen is the element and fluorine is the second element present in the hydrogen fluoride molecule. So choice B represents the correct answer.